Alrighty, today we are ending off our notes prior to this next test with some exponential growth and decay problems. So there really is one formula for these two types of problems. You just need to interpret if it's growth or decay, and that tells you which way you're using said formula. So this is the formula. Our new value is equal to the principal initial times 1 either plus or minus the rate of increase/decrease to the t power. So it's really one formula. Whether you're adding or subtracting depends on if it's growth or decay. So let's start with growth. When I have growth, that means I am adding my rate of increase. So let's talk about what some of these parts are. 1 plus r, that is my little a value. And when I have growth, that means that that value is bigger than 1. I'm adding something to 1, so that number should be getting bigger over time. R is my rate of increase or interest rate. It just depends on the problem because not all of these are going to be necessarily about interest. Sometimes it's about population increase. Sometimes it's about rate of spread. So it's just the rate of increase. And T obviously is still time. So let's look at some examples. On number 1, the original value of an investment is $1,800, that's P. If the value has increased by 7% each year, that's R, write an exponential function to model the situation. So my new value is going to be 1,800 times 1 plus R. 7% as a decimal is 0.07 to the t power. So my function is 1,800 times 1.07 to the t power. That is my function. So on these types of problems, there's going to be two things I'm looking for. Your function, and then the answer for the follow-up question, which is find the value of the investment after 15 years. So when t is 15, I'm going to plug in 15 for t, and then in the calculator, and we're talking about money here, so I'm going to be rounding to 2 decimal places. So $4,966.26. And that's it. Okay, let's do number 2 now. In 2002, there were 972 students, that's my P, enrolled at Oakview High School. Since then, the number of students has increased by 1.5%, that's my R. Write an exponential function to model the situation, then find the number of students enrolled in 2014. So again, my principal is 972 times 1 plus 0.015 to the t power. So that's going to be 972 times 1.015 to the t power. Now in 2014, from 2002 to 2014, that is 12 years. So when t is 12, I'm going to get 1,163 students. And because I'm talking about people, I need to always round up to the nearest whole person because we don't have fractions of a person and we round up when we're talking about people. So let's talk about some key words here. We obviously knew these were growth because they were sectioned that way, but one of the things you'll need to determine is whether we're looking at growth or decay based on key terms. So this one says increased. So that indicated growth. Again, increased, that indicated growth. So increase, appreciate, those are keywords that tell you that we are looking at exponential growth. Let's move on to our other type, which is exponential decay. So that formula, similar to the one before, except now I'm going to subtract R. And so for this one, 1 minus r is my little a value. In this case, a is going to be less than 1 because I am decreasing. R, again, is our rate of decrease. So this could be depreciating, we could be shrinking a population size, things like that. And t is still time. So let's look at 3. An investment of $12,000, that's our P, is losing value at a rate of 4% each year. Write an exponential function to model the situation. So P times 1 minus 0.04 to the t power. That's going to be 12,000 times 0.96 to the t. So there's my function. Find the value of the investment after 9 years. So when t is 9, I'm looking at 12,000 times 0.96 to the 9th power. I'm still talking about money, so to 2 decimal places, that is going to be $8,310.41. Okay, last one, number 4. Mark bought a brand new car for $35,000. That's my P. If the car depreciates in value by approximately 8% each year, write an exponential function to model the situation. So here is my P, 35,000. 1 minus 0.08 to the t power. So that's 35,000. 1 minus 0.08 is 0.92 to the t. Find the value of the car in 2015. Well, he bought the car in 2008, so from 2008 to 2015, that is 7 years. So I'm going to plug in 7 for t, and I'm going to get $19,524.63. So again, keywords that would indicate to me that this is decay: losing value, depreciates, decreases. Those are the words that tell me that I am losing value. So let's look at a couple more as they are mixed practice so that you can indicate whether they are growth or decay. So on the back side, let's look. Vanessa invested $2,500 in an account that will increase in value by 3.5% each year. Write an exponential function to model the situation, then find the investment after 20 years. Increase tells me that this is growth, so my function is going to be 2,500 times 1 plus 0.035, that's going to be 1.035 to the t power. Well, in 20 years, let's figure out how much that is. Again, I'm talking about money, so I know I'm rounding to 2 decimal places. It's going to be $4,974.47. Cool beans. Let's look at number 2. The average price of a movie ticket in 1990 was $4.22. Since the price has increased by approximately 3.1% each year, write an exponential function to model the situation. Increased, that tells me that this is growth. So my principal, 4.22 times 1 plus 3.1%, that's going to be 1.031 to the t power. Well, let's find the price in 2016. From 1990 to 2016, that is 26 years that have passed. So I'm going to plug in 26 for t. And we're talking about money again still, so that's going to be 933. All right, a virus has infected 400 people in a town and is spreading by 25% more people each day. Write an exponential function to model the situation. Find the number of people that will be infected in 10 days. So, again, we are spreading this disease. So that's telling me that this is going to be increasing. So 1 plus 25%, that's going to be 1.25 to the t power. Now, this is spreading by 25% each day. So when I'm looking for 10 days, because my rate of increase increment days matches this days, t is in days for this particular situation. If this was 25% a year, we would need to convert these days to year. But because this is each day and day they match, I'm just going to plug in 10 for t. And I'm looking at people again, so I need to round to the nearest whole number, and I'm rounding up. All right, 2 more to go. The population of a small town was 10,800 in 2002, so there's P. The population has decreased, this indicates decay, at a rate of 2.5% each year. Write an exponential function and then find the population in 2020. So my P is 10,800. I'm decreasing, I have decay, so this is going to be 1 minus 2.5%. 1 minus 0.025 is 0.975 to the t power. So there's my function. Then from 2002 to 2020, that is 18 years. So I'm going to plug in 18 for t. And again, I'm talking about people, so I'm rounding up to the nearest whole person. All right, last but not least, Manny, you bought a brand new car in 2012 for $28,750. If the car depreciates by 12% each year, write an exponential function to model the situation and find the value of the car in 2018. Depreciate indicates decay. So here's my principal. And then 1 minus 12%, 1 minus 0.12 is going to be 0.88 to the t power. So in 2018, if I bought the car in 2012, in 2018, that means 6 years have passed. So I'm going to plug in 6 for t. Again, I'm talking about money, so we are rounding to the nearest cent. And there is the depreciated value of my car after 6 years. All right, that wraps up our notes on exponential growth and decay, and that's the final set of notes you need before our next test.